Hello, this is the 2003 AMC 12A problem number 21. The graph of the polynomial p of x, which is x to the fifth plus ax to the fourth plus bx cubed plus cx squared plus dx plus e, has 5 distinct x-intercepts, one of which is at 0, 0. Which coefficient cannot be 0? A, B, C, D, or E? Well, there are going to be two ways to solve this problem. One is using Vieta's formula in a purely algebraic or mathematical way, and another is using a more logical sense to it. So, if we say R1 equals 0, and then you have roots 0, R2, R3, R4, R5, according to Vieta's formula, you're going to have D equals R1 times R2 times R3 times R4 plus R1 times R2 times R3 times R5 plus R1 times R2 times R4 times R5 plus, this is going to go on for a little bit, R1 times R3 times R4 times R5 plus R2 times R3 times R4 times R5. Okay, now since R1 is 0, all my hard-earned work goes to nothing, and we have D equals R2 times R3 times R4 times R5. Okay, so this is the product of 4 non-zero numbers, which means that D therefore must not be 0 either, which means that our solution is going to be D. You can try these with all the other coefficients and see how it doesn't work. Now, the next way is to think about it in a more logical way. So since 0, 0 is an intercept, the coefficient E must be 0. So if D was also 0, then x squared would divide the polynomial, because then you'd have an x squared. You wouldn't have some line to balance it out, which would not divide the polynomial, which means that it has to have a double root at 0, because it's got two parity or whatever it's called. It's got two it has to have a double root, but that's impossible because you have 5 distinct roots, and then you would only have 4, which means that D cannot be 0. That way you can actually have 5 zeros. So thank you much for watching, and goodbye.